Learn about factoring by greatest common factor and grouping. I think you probably recognize the GCF word, but grouping has not been something that I think you've done before. All right, we have to factor first by using a greatest common factor. Now, I'm not going to do all the factor trees and stuff that I know that you've done before, but you can always go back to that if you like. Okay, the first thing you have to do is find a number that goes into 8, 4, and 16, which are the coefficients. The largest number that goes into all three is the number 4. Now we need to look at the variables. Now you need to think the largest variable that they all have in common. Now I can't say x to the third because this x over here doesn't have x to the third, it just has x to the first. So the largest exponent I can take out that they all have is x. Now I've got to fill in these blanks so that when I distribute it, I get this answer up here. So 4 times 2 is 8. I have an x. I need x squared to make x to the third. So 4x times 2x squared is 8x to the third. 4 times 1 gives me 4, and x times x gives me x squared. The last part, 4 times 4 gives me 16. I have an x, I only need x, so that's the end. I think if you find you distribute it, you will get the exact same answer as the problem you were given. So this is the solution to the problem. That's called factoring with a GCF. All right, let's try another one. Now this problem, example 2, has a negative on both of them. So I'm going to take a negative out as my GCF. Now what's the biggest number that divides perfectly into 14 and 12? 2. What is the largest x that you can take out that they both have? They both have at least an x. Can't do the x squared. Now, I'm going to show you a little bit, sorry, my phone just went off. I'm going to show you a little bit different way to do this time. I can also take the monomial that is your GCF, I can divide by it and put it under here. That's what gives you what goes in the two blanks. So negative 2 goes into 14 7 times, and the x's cancel, so I just get a 7. On the second one, negative 2 goes into negative 12 6 times. X squared and x cancel to give me an x, and that is your solution to that problem. So there's two ways that you can actually work through it. Next time, be careful if you're doing negative 1 and make sure that negative 1 follows down all the way if all you can take out is a negative 1. All right, look at this one. Can you think of a number that goes into 3, 2, and negative 10? 1 is the only number that I can think of. Then looking at the x's and the exponents, we have x cubed, x squared, and this 10 doesn't have an x. So there is no factoring that can be done. The problem is the answer. Example 4. Pause this, see if you can do the GCF. The GCF between these two are a 3 and an x. That's the biggest number that goes into 9 and 6, and that is the most number of x's that you can take out that they both have. Then I've got to decide what goes in the blanks. 3 times 3 is 9. X times x is x to the second. 3 times 2 is 6x, and I don't need any x's because all this has is an x. Okay, now it asks you what the dimensions of the court would be, and the dimensions would be 3x and 3x plus 2. Okay, this next set is going to lead you to grouping. Now, if you look at for a GCF, if you look at this, both of these have a greatest common factor. It's kind of odd, but this has an x plus 2 and the 3x has an x plus 2 with it. So I'm going to take that out front as the greatest common factor. So the x plus 2 is coming out front. I only have to write one of them down because it's coming out of both of them, just like the greatest common factor problems we've been doing. Okay, now what do you have left over? You have 5 plus 3x. And guess what? You just factored that problem using GCF. Look at number 6. They both have a b squared plus 1. And also it has a b squared plus 1 here. All right, so I'm going to take out the greatest common factor, which is b squared plus 1. Mark those off. And what I have left here is negative 2b plus, what do you think would go right in front here if there's nothing there? Yep, you're right, a 1. And that problem is complete. Okay, look at one more problem. And this problem, if you notice that none of these factors have anything in common. So I can try to look at it and look again and see if they have anything the same, but it cannot be factored because they do not have any greatest common factors. Okay, you might be able to factor by grouping. That's the next thing we're going to look at, is doing basically and putting those two ideas together. All right, we're going to try 3 of these problems. Okay, when factoring by grouping, we are going to draw a line right here and find out what the first 2 terms have in common. They have a 2 in common, and the largest exponent that you can take out that they both have is h to the 3rd. Sorry guys, my phone keeps going off. Okay, and then 2 goes into 6, 3. I need one more h, so that h to the 3rd and h gives me h to the 4th. 2 times 2 is 4. This is h to the 3rd. They already have an h to the 3rd, so I'm done. Now I'm going to try the second part. 8 and 12 both have a 4 in common. They do not have any h's in common, so I'm not going to put any h's down. What's left over? 4 times 3h gives me 12h, and 4 times 2 gives me 8. Now I'm to the point where I did a greatest common factor, and now we're going to do grouping. Grouping is when they both have a common factor. I put it in front, take that part out, and then write down what you have left, which is 2h cubed plus 4. All right, let's try example 9. Again, factoring by grouping. It's called grouping because when I draw the line here separating the 2, I'm grouping these 2 together and I'm grouping these 2 together. Okay, let's get started. 5 and 15 both have a 5 in common. The largest exponent I can take out that they both have is a y to the 3rd. 5 times 1 is 5. Y to the 3rd times y is y to the 4th. 5 times 3 is 15, and I don't need any y's because I started with the y to the 3rd and I'm ending with y to the 3rd. Okay, looking at the second part. Y and 3y, y squared and 3y both have a y in common. If you take a y out, that will leave a y, and then y times 3 is 3y. Noticing we both have y minus 3 here, I'm going to take that one out into the front because it's the common factor. Cross it off, and what do you have left? 5y cubed plus y. The end. All right, I think we have another one. Number 10, factoring by grouping. Pause this, see if you can do it, and come back to me for the answer. All right, let's divide and conquer. So I'm going to take the 4 out because they both have a 4 in common. The highest exponent I can take out is an r. I need an r squared, so that r times r squared is r to the 3rd. 4 times 6 is 24. I have an r, that's all I need. Plus, okay, these don't have anything in common, so I'm going to put a 1, parentheses, r squared plus 6. Okay, they both have an r squared plus 6. I'm going to write that down first and cross it off. What do we have left? 4r plus 1. All right, our last problem is going to be factoring with opposites. We're going to start this the same time, but then something's going to happen where we're going to get stuck. All right, divide and conquer. They both have a 2 and an x squared. What's left? X, because that gives me x to the 3rd. 2 times 6 is 12. I don't need any x's, so I can close the parentheses. 3 and 18 both have a 3 in common, and I'm left with 6 minus x. Now, I can't say that these are the same because they're backwards. The only thing I can do, however, is rewrite the first one exactly as it is, change this 3 to a minus 3, and by doing that, it turns it around to x minus 6. Now they have common factors. I can write down the x minus 6 in the front, mark it off, and what I have left is 2x squared minus 3. All right, that's the end. We're going to go over more of these on Tuesday, so bring your notes with you. Remember that you have 3 sets of notes that are due tomorrow. Okay, we had 2 from last week, which were factoring, slip and slide, and the one that we did right now, which is called grouping. Make sure you have all of those ready for tomorrow. All right, y'all have a nice night. Bye.